Okay, this is my third time recording this video, so no matter how bad it is, I will upload it anyway. And this is about matrix representation of linear transformations. Here's the question. Transforms a vector with respect to the basis B into a vector with respect to the basis C. And this is a weird thing because they are not the same basis. It's not even elementary. So you gotta find a transformation that take account of their different bases into account, and also records the information about how it arranges the ABC. So this is difficult when you first look at the question. And I got no idea how to do it, but now I have. And the way to do it is pretty simple. And first you gotta understand the thing. You write down the equation. So this ABC, when you times, let me write it that way. Okay, so just focus on this part, the input ABC with respect to basis B. It can be rewritten as the basis B and if you multiply by the inverse but in both sides, I will just write this part as B. Okay, and the inverse of it is B to the -1 power. It stands for the inverse. B inverse times ABC with respect to B gives you other coordinates. Let's see, x, y, z. That is a linear combination. That is the scalar of the linear combination with respect to the standard, the elementary basis, the 1 0 0 0 1 0 0 0 1. So when you times it by the inverse of its own basis, you get back to the vector that is a linear combination of the elementary vectors. This is good because you can find the linear transformation. You can't really figure out the equation. Oh, let me write the equation first. The equation is just this one, this thing. ABC you can write this part as 2 3 -1 0 4 5 times ABC is the same thing. Just measure the multiplication with respect to C. This whole thing, and we want it to be the elementary, so that we can solve the equation. To write it as the elementary, you can times by the inverse of its basis. Okay, and then you can get the elementary. I guess I should write this x, y, z so that it's easier to understand. Right, you times both sides by the inverse. This is b. By inverse is you get I. For this side you get I times x, y, z. And it's just x, y, z. For this part you got b -1. So I substitute. And also can times this part by the inverse of c. A, B, C. Oh, no, once you times it by the inverse, you get elementary. It's not C anymore. It's elementary x, y, z. The elementary basis. And you can times both sides by the inverse and cancel out, leaves you with that. So t equals c inverse times 2, 3, -1, 0, 4, 5 times b. And yeah, you can just plug in c. This is c. Find the inverse of this. The inverse of c is 1, -1, 0, 1. Because this is adding the second row by the first row, and this minus, subtract. So this is the inverse of c. This is c inverse, and 2, 3, -1, 0, 4, 5 times b. And this will be the answer, the matrix representation. And you can use your calculator or calculate by hand. Here I have it. This is the inverse of c. This is the linear transformation. If the input and output are elementary, but they are with respect to, instead of elementary, but this is different, b and c. This will be the linear transformation, the simple one. But because the bases are different for the input output, you gotta have c. C inverse and b. So you got, this is the answer. This is a question from my textbook, and I checked the answer. This is correct. So this is a correct way to solve this question. I figured it out myself. I think it's better than the way on the textbook, especially if you use calculators, faster. Okay, and also some questions are different. There's nothing. It just transforms vector space with respect to b to c, and you can delete this part, and this will be the linear transformation, the c minus b. Yeah, you can apply this formula to any question, and it should work, as long as you understand how this formula works.